Over the past few weeks, something interesting has been happening in the AI world. A project called OpenClaw has suddenly exploded in popularity. If you follow AI communities, developer forums, or cybersecurity circles, you've probably seen people talking about it everywhere. Some call it the next generation AI assistant. Others say it could change how we interact with computers. Developers are rushing to build their own versions. Startups are launching new products inspired by it. And security companies are trying to integrate it into their platforms as quickly as possible. Whenever something like this happens in technology, there is always a familiar pattern. First comes excitement. Then comes hype. Then everyone rushes to build something before the market moves on. But when technology moves too fast, one thing often gets left behind. Security. And that brings us to a recent incident that perfectly illustrates this problem. An incident involving one of the largest cybersecurity companies in China, Qihu 360, and their AI security product called Lobster. At first glance, the product sounded impressive. An AI-powered security tool designed to help organizations detect vulnerabilities and analyze risks. The name itself even sounds strong and protective. Lobster. Something with a shell. Something that defends. But when independent researchers examined the software package, they discovered something shocking. Inside the installation files, they found something that should never be there. A TLS certificate. And more importantly, the private key associated with that certificate. For anyone who works in cybersecurity, hearing those words immediately raises alarms. Because in modern internet security, the private key is the most sensitive secret a server can have. It is the cryptographic identity of a system. It proves that a server is legitimate. It protects encrypted communications. It allows users to trust that the service they are connecting to is genuine. And there is one fundamental rule that every security engineer learns very early in their career. Private keys must never leave the server. Not temporarily. Not accidentally. Never. If someone obtains a private key, they can impersonate the service. They can intercept encrypted communications. They can perform man-in-the-middle attacks. They can inject malicious updates. In other words, if you have the private key, you effectively become the server. And yet in this case, the private key was sitting inside a publicly downloadable installer. Anyone who downloaded the software could access it. Anyone. It's hard to overstate how serious that is. But it gets even worse. The certificate in question was reportedly a wildcard certificate. A wildcard certificate can authenticate an entire domain and all of its subdomains. That means the private key could potentially be used to impersonate multiple services under that domain. Login portals. APIs. Update servers. Data communication endpoints. If an attacker had that key, they could theoretically set up fake services that appeared completely legitimate to users. Browsers would display the lock icon. Security warnings would not appear. Everything would look normal. Except it wouldn't be. Now the obvious question is this. How does something like this happen inside a cybersecurity company? These are not inexperienced developers. This is a company whose entire business is built around protecting users from security threats. So why would such a basic mistake occur? Many experts believe the answer is something surprisingly common in software engineering. Convenience. The Lobster tool apparently runs a local web interface on the user's machine. To avoid browser warnings about insecure connections, the developers needed HTTPS. The correct solution would have been to generate a local certificate for each installation or implement a secure certificate management mechanism. But that requires additional engineering work. Additional testing. Additional complexity. Instead, it appears that someone chose the easiest path. They included an existing certificate and its private key directly in the installer. From a development perspective, that shortcut solves the immediate problem. The interface works. The browser shows a secure connection. Everything appears fine. But from a security perspective, this is one of the worst possible decisions. It's like a bank making thousands of copies of its vault key and handing them out because it makes operations more convenient. And this is exactly why the cybersecurity community reacted so strongly when the issue was discovered. But what makes this story even more interesting is the timing. Because this incident happened right in the middle of the massive excitement around OpenClaw and similar AI agent systems. Across the tech industry right now, companies are racing to release AI tools. AI assistants, AI automation platforms, AI security analyzers. Everyone wants to move quickly. Everyone wants to be first. But the faster the industry moves, the more likely it is that fundamental security practices get ignored. And unfortunately, the early ecosystem around OpenClaw and similar tools is already showing signs of this problem. Many forks and variants of OpenClaw are being released at an incredible pace. Some are experimental prototypes. Some are built by small teams. Some are modified versions shared on GitHub without deep security reviews. And researchers who have looked closely at some of these projects have already identified numerous security concerns. Hard-coded credentials, unprotected APIs, exposed tokens, weak sandboxing, and in some cases, systems that are effectively running with very little isolation at all. In cybersecurity slang, people sometimes describe this situation as running naked, meaning the system is exposed with almost no real protection. For individual users, that can be extremely dangerous. Many of these AI agent systems have powerful capabilities. They can access local files. They can interact with web services. They can run commands on the system. They can store credentials. If vulnerabilities exist in those systems, the consequences could be severe. Sensitive data could be exposed. Accounts could be compromised. Machines could be taken over. Financial losses could occur. And the average user may not even realize the risks. Because right now, the excitement around AI agents is so strong that many people are installing these tools immediately without asking basic security questions. Where does this software come from? Who audited the code? How are credentials stored? What permissions does it have? How are updates verified? These are the kinds of questions that security professionals ask automatically. But most users simply see the hype and click install. This is why the security Lobster incident matters beyond just one product. It's a reminder that even companies whose business is security can make serious mistakes. And if large organizations can overlook fundamental principles, the risks may be even greater in rapidly evolving open ecosystems. This doesn't mean OpenClaw itself is inherently unsafe. Many open-source communities eventually build strong security practices. In fact, open-source transparency can often improve security over time. But early stages of any new technology are usually chaotic. Features are evolving. Architectures are changing. Security models are incomplete. And that's exactly the phase we are in right now with AI agent systems. So the message here is not fear. The message is caution. Developers should resist the temptation to rush products to market without proper security architecture. Cutting corners may save time today, but it can create major problems tomorrow. And users should be careful about blindly installing experimental tools that have deep access to their systems. Especially tools that interact with financial accounts, sensitive data, or critical infrastructure. In cybersecurity, there is a principle that has existed for decades. Move fast if you want. But never move fast with secrets. Keys, credentials, certificates, access tokens. These things must be handled with extreme care. Because once they are exposed, the damage can be very difficult to undo. At the end of the day, the most important lesson from incidents like this is actually very simple. Technology may evolve quickly. AI may transform how we work and build software. But the fundamental principles of security do not change. Private keys must stay private. Sensitive credentials must be protected. And convenience should never override security. Because in the digital world, trust is incredibly fragile. It takes years to build. But sometimes only one mistake to break. So as the OpenClaw ecosystem continues to grow and new AI tools appear almost every day, it's worth slowing down for a moment. Excitement is good. Innovation is good. But strong engineering fundamentals are still the foundation of everything. Without them, even the most exciting technology can become a risk. And in cybersecurity, the difference between innovation and disaster is often just one decision. Protect your systems. Protect your data. And most importantly, protect your keys.